Hello, everyone. Good morning. Welcome to the conference. Hopefully, our mobile products and our launches today will get you excited about building new applications. But the core of it all is Couchbase Server, which is near and dear to my heart. And at Couchbase, I manage product roadmap for all the products, Couchbase Server and Lite and Gateway. Today in this session, we'll talk a little bit about what Couchbase Server is, a high-level overview of the product, a live demo, and most importantly, I'll actually talk a little bit about the new features that we've released over the last year, with 2.0 being released today. What are some of the features? We'll take a peek at it as a part of the live demo as well. It'll probably be a quick-hitting session. There's lots to talk about. But at the end of it, what I'd like you to take away is the functionality of Couchbase Server, what are the strengths, how it works under the covers, the architecture, and what are the new releases, what are the new features that you could use if you're already in production for your future releases. Couchbase Server is based on the Couchbase open source project. It is an Apache 2.0 project. We have our community edition as well as enterprise editions available. Today we released our Couchbase Server 2.2 enterprise edition, which includes a lot of great features. So we'll take a look at what those are. So just a little bit about what I'm going to talk about today. We'll take a look at the features of Couchbase Server, what's new in 2.1 and 2.2, an architectural overview, and then if the demo gods permit, hopefully a live demo as well. All right, so in terms of Couchbase Server, there's really 4 key characteristics that define it, that differentiate it. The first one is easy scalability, and we'll see this in action through the demo. Easy scalability for you, it means easy elasticity, adding nodes, removing nodes, growing your cluster as and when needed, while the application is up and running, no downtime at all. And this is really important for interactive applications that run 24/7, where really there isn't a window even between 2 a.m. and 3 a.m. Well, which time which time zone will that be in, right? And so easy scalability is incredibly important. Moving on, consistent high performance. Some of these interactive applications really need low latency. And when we talk about low latency, it's in sometimes the microseconds. There are some customers who see 100 microsecond responses, could be a millisecond. Ad targeting, for example, is one where if the latency is increased beyond 3 milliseconds, we probably get a call for the support team to see what's going on. And so with our built-in cache, it gives you the high performance, and that's high throughput, as well as low latency. Always on, 365. This is more to do with operations. When you are up and running a database in your production data center, the last thing you want is the system down. And so we achieved this always online capability with intra-cluster replication, inter-cluster replication, which is XDCR, as well as by providing a lot of tools to help you recover data just in case things go wrong. And in 2.1 and 2.2, we actually have added a few more optimizations and tools to help you keep your cluster healthy as well as recover fast. And then finally, a flexible data model. We see that most applications being built today are built on JSON, and that's what gives you the schema flexibility. No need to change schemas in the database. Your application can manage data as it's changing on the fly, particularly if you are managing third-party data that you don't have a control of in terms of the schema, in terms of the number of attributes that might be a part of that JSON document. And so JSON flexibility allows you to build richer applications and also rapidly push those out as needed. So let's take a look at some of the core features. We have built-in clustering. What this means is all nodes are equal, they're all identical, and no node is really special. So if a node goes down and another one can take its place. Every node has a data manager and a cluster manager, and we'll take a look at the architecture in a bit. Data replication. So this is intra-cluster replication with failover. You can have automated or manual failover. No downtime with upgrades. a built-in cache, which is influenced by memcached, and an append-only storage tier for faster writes. So what this means is that when you're writing to disk, we always append to the file so that the writes are significantly faster. Compaction, indexing, a lot of operations in production, admin operations are online, so you don't have to take your application down. And we have a great UI along with SDKs to help you monitor and build your application. So with 2.0, we introduced a lot of new features. I'm not going to go into each one of these. We'll actually take a look at it in the demo. But most interestingly, in 2.1, let's see what's new. So as some of you know, we have a persistence tier, which asynchronously persists data to disk from memory to disk. And with 2.1, we've rewritten that engine to make it a lot more powerful. It's now multi-threaded. And what that means is you can tune based on the application requirements what number of threads a bucket might need. So you can have different threads per bucket based on your applications. Optimistic XDCR, we like to come up with names like optimistic to give you a good feel. But more than that, it reduces the latency of an XDCR request. So when a mutation comes in with cross-data center replication, with 2.0, we did a check initially to the remote cluster asking, do you need this data? Now we don't do that check anymore. You have a mode where you can say, I don't care as much about bandwidth, just send over the data directly, even if it's not needed on the other side, so that I save all my latency requirements across clusters. Health check tool, later today there will be another session that goes into more details. And hostname management, this has been a little bit of a pain point in the past where we've used IP addresses. Now you can have static names, static host names that you can assign to clusters and nodes individually to get them set up. And a little bit more with rebalance progress indicators. But today we released 2.2, which is another minor release of Couchbase Server, but it has major new features. So we've introduced a new XDCR protocol. Version 2 of the protocol is a lot more optimized. It directly uses the memcached protocol, which is extremely efficient. In addition, we've introduced a read-only user. And this is something that a lot of customers who talk to me ask me every time we have a call. Can I have, you have a beautiful UI. It's just that I can never share that username and password with anyone because they might flush the database, delete the database, change things that I don't want them to. And we'll see this in action today. And a few new features. CB recovery is one where it allows you to recover partitions, missing partitions, at a very granular level from another remote cluster if you have one. So if you already have a remote cluster set up, you could just find the missing partitions on the source cluster automatically, and it will recover your data. So just a quick tip for the conference. You can learn more about keeping your cluster healthy 4:30 today. We'll deep dive into the health checker tool, as well as other monitoring capabilities as well. So now let's take a look at the Couchbase architecture under the covers. As I mentioned initially, each server has a data manager and a cluster manager, and every node in the cluster looks identical. So it looks exactly like this. Within it, inside, the data manager manages the cache as well as the multi-threaded persistence engine that I talked about, as well as the query engine. And then the cluster manager manages all cluster-wide activities like replication, rebalancing, even the UI, REST, all the REST APIs and so on. And this is what gives the cluster one look and feel. So when you log into our UI, you will basically see a cluster-wide view. You can deep dive individually into servers, into buckets as needed. Now, within a node, within a single node, how do operations in Couchbase work? So what exactly happens when a read request comes in or a write request comes in? So let's take a look at what actually happens within the node. For a write operation, you have, let's say, doc1 that comes in. It gets stored into the managed cache. And at that point, it is accessible to everyone that's accessible to the application. So all clients will now have access to it. It's strongly consistent, which means that there is no way another node can have another version of it. You have one view of your data because there's really only one location that we allow for reading and writing data to. In 2.1, we've actually added replica reads in case you need it. But typically, Couchbase doesn't need replica reads for read throughput scaling. It's powerful enough that you can just use the active server. But in case of availability, if a node is down, you can actually use replica reads to read potentially dirty data from a replica. Once it gets into the managed cache, it gets pushed over to the replica via the replication queue, and also gets persisted down to disk to get, which is permanent, and it's at that point, it can get picked up by XDCR, it can get picked up by the indexer, and so on, other features, other functionalities of the database. An update operation is pretty similar. So you have a document that comes in. Again, it's strongly consistent, and so the managed cache has the latest copy of the data. So you have doc1 prime that gets updated in the cache. It obviously gets pushed to the replica, as we saw earlier, and also gets written down to disk. A read operation is pretty simple. So if this is typically like you would expect from a database, document request comes in, doc1 goes back out. Of course, if it's not in the cache, it will get fetched from the disk and then put into the cache, at which point it becomes a part of the active working set. So that's when it's, becomes a part again of the actively managed working set, and then gets sent back to the client. So we've taken a look at the individual node basis. Now let's take a look cluster-wide and see what happens. Across the cluster, let's say we have 3 nodes. Every node is identical, and every node manages a part of the data. So server 1 will have a set of data. The replicas will live on potentially different servers. For example, document 9 lives on server 1, but the replica lives on server 3. And when you add the application server and the client tier to this, you'll see that the clients are smart clients, which means that they have the cluster map. They know exactly where the documents are located. So when a request comes in, they know that document 5 belongs to a specific partition, what we call vbuckets or virtual buckets. And that virtual bucket lives on server 1. And so it directly accesses server 1 to get access to that document for reads, writes, or updates. Well, the next thing is what happens when you add nodes to the cluster. How does the data actually move around? And what happens during that time, right? You can add multiple nodes at a time to the cluster, and I'll actually demo this exact same thing later today. The replicas get moved, active and replica documents get moved over. During this process, you basically have the application up and running, and all our rebalances, all our cluster-wide operations happen at a vbucket granularity or at a partition granularity, which means that until the partition is completely moved over and the takeover is complete, the client will keep sending requests to whoever owns that partition. And once the cluster map gets updated, the request will get sent over, instead of cluster server 3, will get sent over to server 5. And so the add operations allow you to continue to run your application while you're rebalancing the server, the cluster. And then bad things do happen, unfortunately. So what happens in that case is you can either perform an automated failover, where the cluster itself, within 30 seconds, will basically notice that a node is down and will fail over the node, promoting the replicas. You also have the option of doing manual failover. And so when that happens, the replicas, as you saw here, are uniformly distributed across the cluster, and they all get promoted. And so there's not one server in particular that's taking on more load. All the nodes in the cluster are doing a little more work, which is obviously a better way to go to prevent failures moving forward. So you can learn a little bit more about production and how to run in production in Perry's session. But right now, let's actually jump to the demo here. And as you see, I have a workload running. It's about 2.5K operations per second. I'm running these on AWS instances, so I have a couple of instances set up. The first cluster is a 3-node cluster, as you see here. You see that some of them are IP addresses, some of them might be DNS names, because now we support host names. And you can drill down into each of these areas to actually see what's happening. In terms of, I have about 600,000 items in here. And we will see, I have a couple of other nodes set up. So this is a single node server. It's not a part of the cluster yet. And I also have a cluster server that's not set up. So let's see how easy it is to set it up. So let's get started here. You see that you get asked a few questions. You can set the paths. You can say if you can even join a cluster if you want to. The next step is selecting some sample data if you'd like to. But what I'd like to point out is actually the disk read-write concurrency. And this is where you can change the number of threads you want for the bucket, which is new to 2.1. So for now, let me just go ahead and enter a username and password. We also have the ability to reset a password using a command line parameter in our latest release. So now that these are set up, let me go ahead and add these to my cluster here. So I have a 3-node cluster. Let's go ahead and add both the servers in. All right, it seemed to work. Let me try another one. That's why I was praying to the demo gods earlier. Seems like it's already a part of the cluster. So let's try another one. All right, let's get it going. And at this point, you can hit rebalance to start rebalancing the cluster. And at this point, you can see the data being moved around. You also have a lot more information. So now you see that you can actually monitor the number of keys that are needed, the number of vBuckets that need to be moved. So it's a lot more granular. You can actually see what's going on with the cluster in real time. Now, let's actually set up a few things. So let's go back to the slides and actually talk a little bit about indexing and querying and XDCR and see how that works in the cluster. So with indexing and querying, we've added this functionality so that you can look inside a document, create a materialized view, and actually query that view. When you create a view, which is essentially a JSON, a JavaScript map function, it creates the materialized view for a subset of data that resides on that server. So in case of server 1, it will create the index for that piece of data. And so with server 2 and server 3. And then when the query comes in, it can come into any node in the cluster. The server that picks it up becomes the coordinator for that query and redistributes the data across to the other servers, sends the request, and at that point, the indexes for the individual nodes will get searched. You might have a ranged query. You might have a specific key lookup. The results come back, get aggregated at the node, at the coordinator node, and get sent back to the client. And so that's the way indexing and querying works. You can have, with indexing and querying, we also have aggregates. We have reduce functions, so you can create custom reduces if you like. And towards the end of the session, I'll talk about the next step for us in terms of indexing and querying. Now let's talk a little bit about cross-data center replication. This is something that we get a lot of questions about. There's a lot of interest. We have customers in production running today. And it's a great feature because it's so easy to use. So let's take a look at what happens like we did in the case of a write operation. Now if you've set up XDCR, same thing happens. A document comes into the managed cache, gets sent over to the replication queue. In this case, it's the intra-cluster replication queue, gets persisted to disk. And at that point, the XDCR engine will actually pick it up and send it across the WAN to the other cluster. That's, let's say, a target cluster. Now, XDCR is on a per bucket basis. So if you have 3 buckets, you can maybe replicate only 1 to the other cluster because that has the most critical data, right? It is extremely scalable, which means that, again, it's an operation that happens on a per partition basis. And so if you keep growing the cluster in size, your partitions get distributed across those clusters, and XDCR throughput can scale horizontally as well. So if it's across clusters, let's take a look at it with clusters and see how it works. So let's say we have a data center in San Francisco and another one in New York. The first thing you can do is set up unidirectional replication. Unidirectional replication can then be used in many different forms to create complex topologies. The next one could be bidirectional, where you have 2 unidirectional ones pointing to each other. But then you can go to a tree structure, a hub and spoke structure, and so on to create slightly more complex topologies. With 2.1, we added optimistic replication. It basically allows you to set a threshold. If the size of a document, a mutation coming in, is larger than that threshold, it will first check if it's needed on the other side. Otherwise, it will just be sent across the wire, skipping 1 round of a lookup. Next, we've added per replication tunable parameters, and we'll take a look at how these work. We also have, in 2.2, an optimized protocol based on Memcached, which is extremely resource efficient. And so on your target cluster, you will not see as much of an overhead. And then finally, with all these together, we've built reliable and high-performance replication at scale. So let's take a look at what that looks like. So here we have the 3-node cluster that we were taking a look at. You see compaction is going on at the back. It runs automatically based on a threshold. The bucket itself has the workload running, and you can see a fragmentation threshold. So once it goes above 30%, compaction starts off automatically, and it will clean up the files. Next, let's take a look at the views. So the materialized views allow you to look within the data, right? Here I have a simple view created as a development view. You can see that it's JSON data that I have here with maybe a user profile with name and email and city, country, and so on. And I might want to group by or get all the results back for a particular country and a city. You can also create a primary key index. You can add reduces to this as well to do more complex querying. And here, let me just take a look at the development time subset, which runs it on a subset of data, and you can run it across the full cluster as well. So it's always pre-sorted. You can filter the results in different ways. So you can do descending, for example. Let's take a look at what that means. So you see that you have a different number. We started off with 0, 0, but now it's descending order. You can do range queries with start key and end key, and you can also do specific key lookups with materialized views. Now let's take a look at cross-data center replication. So the first thing you do is create a remote cluster reference. And the cluster reference essentially points to another cluster. I have another cluster that I've set up here, which is a 4-node cluster on EC2 as well. And this, at the moment, does not have any data. So there's a default bucket, but it doesn't have any data at the moment. But let's take a look at, let's bring up the incoming XDCR operations to see what that will look like once we start it off. So once you've created the cluster reference, you pick a bucket that you want to replicate. You pick the cluster reference, in this case, far, far away. And you pick the default bucket that you want to replicate information to on the other side. Now, as an advanced user, this is where we have a lot of per replication information. So you can actually, if you have more powerful boxes, you can maybe bump this up to 64 or maybe lower it to 16. And that will basically change the number of threads that XDCR uses to send information across. You see here that we have additional information, but most importantly, I'd like to point the optimistic replication threshold. And this essentially allows you to say, if my mutation coming in is less than 256 bytes, don't worry about checking, just send it across the wire, and that would save you the round trip. So for now, let me just change it to a slightly bigger number, about a K, and hit replicate. At this point, it's going to start replicating data across. Our workload continues going here, but we see that we have an outbound replication now, which actually has a queue of about 500K. You already see it going down on one side. And on our other cluster, which is our source cluster, you see that it's already receiving these replications at 20,000 ops per second with the number of items, bump that up, with the number of items constantly increasing, and we're already at the point of 600K, which was what the amount of data we had on the source cluster. So at this point, what it does is it basically starts replicating at the speed, at the same speed of the source cluster, and so you start picking up the mutations in real time based on what's going on here. So let's take a look again at our source cluster, about 2,500 ops per second. Some of them it's a mix of gets and sets. And so I think I've set this to a 6-to-4 ratio. And so at that point, it will start, it has all the data, it's current, and it's only now sending mutations across the wire. Quick question?
What size Amazon images are you working with?
This is, I believe, large.
M2 large?
Not M2, I think it's just regular large. Yeah. We'd recommend at a minimum extra large for production. We have customers who are kind of across the board. M2 double extra large. There's some high CPU instances as well. Depending on your workload, you might want to pick the right instance. On physical hardware, the database has a tunability to use more resources. So if you give it more power, you can tune the number of threads up, for example, for XDCR, or even the persistence threads, you can stream those up further to use more disk I/O. In fact, here I've set this up with a new setting. So if I actually take a look at my source cluster, and I go to the server, the data buckets, and actually take a look at the bucket, when you edit the bucket, you can actually change the disk write concurrency. And in this case, I've actually set it to 6. So I've actually bumped it up from the default from 3 to 6, and you can tune it based on your workload. Note that when you change the threads, it might reset the system, so it's not something that you should do in production. Think about it beforehand, and then you can change it later. All right, so compaction is in progress. It seems like XDCR is still going and is moving fine. And again, now you're back to your 500, 600 ops per second mark just for the sets. Obviously, there's more read operations happening on the source cluster, which do not get replicated across. Question?
So I have a question with the multi-data center application.
Yes.
Does it use any connectivity to have that's available, or do you need to set that up within the infrastructure, like set up a VPN?
Correct.
Browse, that kind of thing?
Correct. So it assumes that connectivity exists. So for example, these are in the same region, I believe. So they're both on east, which is not the best data center, but it assumes that there is connectivity. If you need to have a secure application, then you probably want to have a VPN set up. Amazon has a lot of different ways to do that. They have gateways that you can have on both ends that you can use. And of course, with security, there's always a slight penalty on the performance, but it might be more important to you than the penalty on performance. So what else is new in our Couchbase world? And there's a lot of things going on today, particularly this week, along with Couchbase Lite, a Couchbase Server 2.2. We are also releasing a developer preview of a Couchbase query language called Nickel. So read that as Nickel. And if you don't have your chocolate coins yet for the Nickel, go and get them. Nickel is our next generation query language for JSON. And every now and then with Couchbase, you might store so much data in there that you might just want to run a select from bucket where doc.name.first equals Dipti. And well, now you could try that out with our developer preview. It's in developer preview today, and you can learn more about it at the session at 1 o'clock. It's in our developer track, or visit query.couchbase.com. There's an online tutorial that's available for you to try it out as well. With that, thank you very much. I'll maybe take a couple questions before the next speaker comes in. Thanks, guys. Right, any questions? I can come up with some, need it. Yes?
Is there an overhead keeping the cluster maps updated and consistent between clusters?
There are other overheads in the system. For example, XDCR needs to be sized and so on. Of the overheads of the system, the cluster map being kept updated is the least of the overheads. So it's extremely efficient because it is a pull-based model. On the client side, the way it works is each client has a cluster map, and it knows where the partitions live. So it's talking to a specific partition, and all of a sudden that partition basically says, not my vBucket, which means, or the server says, not my vBucket, which means that this partition doesn't live on my server anymore. I don't own it anymore. So there's probably a change, and so go and look it up. And given that these partition changes and the rebalance is at a partition level, it's not happening all at the same time. And so clients will automatically look up the cluster map as needed based on what requests they're getting. And so it's not a huge overhead in the system. Now, within the cluster, it's obviously you're not going to split the cluster across the WAN. We don't recommend that. There are some customers who do that, but we don't recommend it. And within the cluster, you might have a 1 gig or a 10 gig interconnect, and it's not as much of an overhead within the cluster. Was there another question? When we say 1 millisecond responses, we're actually talking about not just what the database takes, but actually a round trip. So basically, we count it's the time between the request being sent from the client over to the server and back. And so it actually accounts for network. Given that the data is in memory and all these operations are actually being performed on memory, that's what gives you that performance. Now, within the client itself, we might do some things like that. For example, I believe that if we have requests for the same document multiple times, it has some capabilities to actually send a request, receive those requests only once, and it dedupes that, for example. But the performance is really because of the cache and the server side. Because if you look at a relational database, you're probably going to do a page fetch, or because you have a buffer pool manages your pages. They're typically 4K, 8K, right? But the cache is actually at a document level. So you're doing a document level access as opposed to a page access. Question?
Regarding security, what's available, what's not available?
Sure. Actually, talking about security, one thing I just want to point out is, which I forgot, is if you go to the settings, and right now I'm signed in as an admin user, we now have a new account management tab right here, and you can actually create a read-only user. So, so let me create one called "You are not admin," and create the user. Now, let me log out of here for a minute. You are not admin. And sign in. And now my view is a little bit different. So you see the account management tab is gone. On the server tabs, I don't see my edit buttons anymore. My buckets don't have any edit buttons anymore. In fact, even the document view button is gone. So you can't even view data. You can only see view definitions. So if I look at views, I can only see the view definitions. You don't see any of the sample data anymore. And you can't do much with replication because you can't change anything. So this allows you to actually really give developers, other folks, a way of looking at our charts, looking at monitoring without really giving them access to delete or flush the database, which will be extremely useful. In addition to that, we've added on the memcached protocol, we encrypt the passwords for the buckets. We've made sure that passwords in general are a lot more secure. No log files have them, and so on. But that's just the first step. What's on the roadmap is SSL for XDCR, for example, SSL within the cluster, encryption of the entire stream coming into the bucket, and those are all on the roadmap. Last question?
Just a question on write performance.
Yeah.
When are writes acknowledged? When after the replication is done, or at what point is write acknowledged?
Sure, and you're asking from the client perspective, right? So from the client perspective, there's many options. So the default is that you send a request to write. It gets written to the cache. At that point, you get an acknowledgement back saying that, yes, I've got it, right? Next, you can, on a per mutation basis, say that don't let me know you have it until it's replicated to one other node. And so you can say replicate to one in your per document mutation basis. And in that case, it will wait for it to replicate to one node and then respond. So you have the option of what penalty or what price you want to pay, because for some pieces of data, they may not be as important, but if it's a monetary transaction or even a user ID, a new user ID creation, you might want to see if it's replicated to one. You also have obviously the option to persist. That's going to take longer, and so we use replication as durability. And then for XDCR, it's completely asynchronous. So you don't really have a capability of saying that, but at the same time, it's multi-master, right? So you might actually have another application that's running on the other side, and we have conflict resolution to actually break conflicts. All right? All right, I think that time's up. Thanks, everyone.